Hi everyone. We have the first class for limits of a function. We have four problems we want to solve here. We want to find the limit of 1, 2, 3, 4 functions. This is for you to try and tell me what you have in the comment section. But before we start, basically the limit of a function that depends on x is such that if this x approaches a value, let's say a, then this function will be also very close to L. In other words, the limit of a function such that f of x, if this x approaches a, then the limit will become L. Mind you, x approaches a and not equal to a. This is like when we say 9.0001. Yeah, when you have something like this, approximately, or we can just say 9 because it is very, very close. Yeah, or let's say 9.000. Let this one be 1 and this one is 2. So this is very close to 9. This is very close to 9. Yeah, so when x approaches a, then the limit will also arbitrarily approaches the limit to be L. All right, but let me reserve the definition of limit for the advanced cases when we are done with everything concerning the basic of limits. Now let's see how we evaluate the limit of these functions. The first one is to find the limits of x squared minus 3x plus 4 when x approaches 1. When we say x approaches 1 or approaches a value, it is just arbitrarily close but not equal to. But when we want to solve or substitute or evaluate, we can use that value because it is almost close. All right, this one is a polynomial function. It is continuous everywhere, whether x is 0, whether it is half, it is 10, it is negative, it is fractional, it is continuous everywhere. So therefore, here to find the limit, we substitute directly. Yeah, so we say x squared minus 3x plus 4. So because x approaches 1, x is very, very, very close to 1, we can accept x to be 1 by substituting it here. So x is 1, 1 squared minus 3, x is 1 plus 4. 1 squared is 1 minus 3 times 1 is 3 plus 4. So 1 minus 3 is minus 2. Minus 2 plus 4 is plus 2. So the second one says the limit of 3x squared minus 2x plus 5 over x squared plus 1 as x approaches 0. You need to pay attention. When you have a polynomial function like this, you don't need to worry about anything. Just substitute. We only have conditional cases like if here it approaches infinity, whether it is positive infinity or negative infinity. But the fact that it approaches what? An integer, 1, 0, positive, negative, fractional, yeah, 0, that one you can substitute directly, except if it is like what? Infinity, we have different cases. But we don't want to go to that now because we don't want the time of the video to go longer than expected. Now listen to the condition when you want to find the limit of a fraction. Normally we say a rational function. Yeah, a function of the form or a fraction of the form a over b where the denominator is not equal to 0. So we call it what? A rational function. But the denominator at this one here must not be 0. So what do we do to find the limit of a rational function? The first thing you do is to try, like what you call you test by direct substitution. You substitute this one here. If it gives you 0, there is a problem. If it does not give you 0, well, you can substitute directly. You substitute this value here, the denominator. If it is 0, well, we don't accept that. If it is not 0, that means you can substitute entirely. I hope that one is clear. Okay. So now we say 3x squared minus 2x plus 5 over x squared plus 1. So this is 3. What is x? We say 0. X is not equal to 0, but it approaches 0, arbitrarily close. So we accept it. Minus 2, x is 0 plus 5. So x is 0 squared plus 1. 3 times 0 is 0. Minus 2 times 0, 0. You don't even need to write all this. Plus 5 over 0 squared is 0. 0 plus 1 is 1. So what do we get? 0 minus 0, 0 plus 5 is 5. 5 divided by 1 is just 5. So do not forget finding the limit of a rational function before you substitute like what I did. The first thing you do, take this value, substitute only in the denominator as to whether it will give you 0 or not. If it gives 0, there is a problem. There is something else to do. So if you want to copy, pause the video, then you can copy. Now let's go to 3 and 4. Now the third one says to determine the limits of the square root of x squared plus 5 when x tends to 2, when x approaches 2. Now, what is the condition for finding the limit of radicals wherein we have roots? Well, the target is that, come to think of this, we have 0, 1, 2, 3. Yeah, minus 1, minus 2, minus 3. Yeah. When you find the square root of 0, it will give you 0. No problem. The square root of 1, it will give you 1. The square root of 2, it gives 1 point something else. The square root of 3, 1 point something else. The square root of 4, it will give you 2. How about the square root of minus 1? Yeah, numbers are broadly divided into 2 major categories. We have the complex numbers. Yeah, we have the complex numbers and we have real numbers. Yeah, so unless if you are dealing with complex variables, then you can say the square root of minus 1, of course, it is I. But for only those who have treated complex numbers, understand what I just did here. Yeah, like if you say the square root of minus 4, well, this is like 4 times minus 1. Square root of 4 is 2. The root 1, root of minus 1. Root of minus 1 is I. Then this is 2i. But it doesn't mean that because we can give answers to this, so everywhere you see this one or the need arises, you can just do it. No. What we are doing now is just real numbers, normal functions. We are not in complex variables. But in complex variables, it's normal. But here we have to recognize that the square root of a negative number does not exist. So we don't want the square root to be the value inside to be negative. So therefore, before you continue, substitute this one here first and see if what you get will be 0 or more. If it is going to be greater than 0 or equal to 0. Finding the limit of square root, substitute this one here first and see, is it 0 or more? If it is 0 or more, no problem, substitute direct. Once you know that if you substitute this one, it will give you a negative value. And the square root of a negative number does not exist except for complex variables. Okay. So let's see. Now, if we substitute 2, before we go on, 2 squared is 4, 4 plus 5 is 9, 9 is positive, it is even greater than 0, then it is normal, it is okay. So therefore, we can say the root of x squared plus 5, x approaches 2, arbitrarily close. So we accept x to be 2. So this is 2 squared plus 4. 2 squared is 4. Oh, sorry, this is 5. 2 squared is 4 plus 5 is 9. Square root of 9 is 3. This is the limit of this function. The fourth one says the limits of x minus 4 over x squared minus 16 as x approaches what? 4. This is a rational function. Rational function, to find their limit, there is a condition as I explained here. So the first thing we do, we substitute here if it is going to give us 0 or not. Okay. Now, if x is accepted to be 4, so it will be 4 squared. 4 squared is 16. 16 minus 0 is what? Is 0. And for rational functions, we don't want the denominator to be 0 because it will become what? It will become undefined. It will become undefined. This is one of the indeterminate cases. One of the indeterminate cases like 0 over 0. This one is indeterminate. But mind you, if only the numerator is 0 and the denominator is not 0, no problem, because 0 divided by any value so far, it is 0. Any value. But 0 by 0, it is indeterminate. Yeah. So any value divided by 0, it is undefined. So for rational functions, the target is that we don't want the denominator to be 0. So owing to the fact that if we substitute directly, the denominator will give us 0. So we cannot do so. We need to do something else. Now see what we do. At the top, we have x minus 4. This one is x squared. But 16 is the same as 4 squared. I hope you agree with me. 4 times 4 is 16. All right. So now this is x minus 4 over difference of 2 squares. I did this one in algebra. Yes, under factorization. Search for the videos. So difference of 2 squares, we have 2 brackets like this. The first base minus the second base. You go again, the first base plus the second base. If you start with minus, you say plus. Plus, minus. Wherever you start, no problem. X minus 4, x minus 4. What remains at the top is 1. At the bottom is x plus 4. Is this the final answer? No, this is not the final answer. So now that we have 1 over x plus 4, what is next? As x approaches 4, so now we say 1 as x approaches 4. So 1 over what is x? 4 plus 4, which is 1 over 8. So this is like escaping the concept that if we substitute directly, the denominator will be 0. And we've escaped that. You can see what we have now. Wherein the denominator is what? Not 0. Thank you for watching. Don't forget to follow, like, share, and comment. See my next video. Try this and tell me what you have in the comment section. See my next video.